Hello and welcome to our discussion of topographic maps. You'll be using these sets of discussions and examples to complete your labs on topographic maps. We'll be covering 8 topics: reading latitude and longitude, public land survey coordinate system, the universal transverse Mercator coordinate system or UTM grid, reading how to read contour maps, contouring data, so starting from blank or raw data and to create a map, calculation of slope on a map, or gradient, sometimes referred to, measuring distances, and then creating topographic profiles. So first we'll talk about reading latitude and longitude. In particular, we're going to cover the area of the units of latitude and longitude, and then reading a map. Here you see a model of the Earth. It's been cut away, and we're going to talk about how we measure and why we measure, and the units that we measure latitude and longitude. In this diagram, you can see that you have a grid that covers the Earth, and that there are places where these lines I'm drawing on here on the Atlantic Ocean intersect and give us a unique location on the surface of the Earth. So for every system we use a grid, we will need 2 lines. Lines of latitude are drawn east-west, okay? But we measure them north-south. Lines of longitude are drawn north-south, but we measure them in the east-west direction. The units we primarily use are shown here, and those units are degrees. Why do we use degrees? Because we're actually measuring or using the angle inside the Earth here between this line, or what we call a parallel, and the equator. We're measuring that angle, and we find that it is 40 degrees, and so this becomes the 40th parallel. If we measure the angle here in the horizontal plane along the equator, right, so we're measuring a line of longitude, we measure from the equator out to that particular line, we find it is 50 degrees, and so this angle in here is actually 50 degrees, or 50 out of 360 degrees in a circle. And so that's how we're going to measure and make measurements. Now, there are smaller units or increments to be looked at, and we'll talk about that because we're commonly going to want higher precision than what you're seeing here. If I put a random point on the globe, let's say right there, and that I put a new red dot, well, we can read straight off the globe that this is the 40th parallel, so it's 40 degrees to the north of the equator, which is down here. Note that the highest value you can have top to bottom, okay, or for a line of latitude, is 90 degrees. Coming back to our example, which is over here in Asia, okay, we're on the 40th parallel, so this is 40 degrees. And then we're also sitting on this line of longitude. And so if we start at 50 down here, we're 50, 60, 70, 80 degrees of longitude. Okay, so the longitude here is 80 degrees to the east, and it's to the east of this line here, which is what we call the principal meridian, or the 0 line. And then we also have to note if it's north or south of the equator, and so we know that it is actually, for latitude, I'll abbreviate that as well, it's 40 degrees north of the equator. If it was 40 degrees south, we'd add an S. Okay. If we focus in on a smaller map, what we find is that there are additional units we need to be concerned with. So if you take a look at these map corners that are shown here, you'll see at the top here we've got a line of longitude, okay, and then on the side written here is the line of latitude. You'll notice the degrees symbol here, but you'll also notice there's a tick mark and a double tick mark, or a quotation and a double quotation. The single quote, okay, is for minutes, and the double quote is for seconds. And in general, the way this works is that for every minute or for every degree, there's 60 minutes. So 60 minutes per 1 degree of latitude or longitude. It doesn't matter. And then if we have minutes, we also need to have smaller increments of minutes. So for every, there are 60 seconds, I'm drawing the double quotation, for every 1 minute. Okay? So we can dice these up into smaller units. Now what you're seeing here are the edges of a topographic map where we have the, and I'll just write this out here, latitude written here on the left bottom and the longitude written here. So I'll highlight these in different colors. Here's latitude, and I'm going to draw my latitude as a green line coming across, and then here's longitude, right, and I'll highlight longitude, and I'll draw it as a blue line coming down. Okay, the same issue down here on the bottom right. This is a line of longitude, and 49 degrees 30 minutes is a line of latitude. If the map is large enough, they'll just write everything out, and you'll have degrees, minutes, and seconds, or just degrees if that's the case, written out along the edges of the map. However, many maps are smaller or written in different ways, and so we have to pay attention to what's going on. In this case, you see smaller units on the sides of the map, here and here. And if we were to look at these and try to read them, right, what this says is that there's an additional 5 minutes between here and here. So if I read east to west, this is going to be 114 degrees plus 5 minutes. So I've gone from 0 minutes here to 114.5 there. Now this is 49 degrees 30 seconds of longitude or latitude, and I'm in the top northeast corner of this particular map. So if I go down, then I need to actually consider moving down towards 0. So I'm at 49.5 degrees or 49 degrees 30 minutes, and I'm going to be heading south, and I'm going to be heading towards the equator. The equator is 0 degrees 0 minutes 0 seconds. So now the change here is what? It's 30 down to 25. So this is actually 49 degrees 25 minutes. So this is a 5-minute change. If we come down this distance here, this is 49 degrees 20 minutes. So this is a 5-minute, sorry, let me erase that, 5-minute change. All right, so if we take a look at this topographic map, we can start by writing out, or at least labeling and talking about the values for some of these locations. In this case, let's start with A in the top left corner. A has an arrow that points it to the top left corner exactly of this particular map. On the right-hand side, we see a line of longitude written above the line of longitude. So longitude runs north and south, so the edge of your map is a line of longitude. And then latitude here is running east and west, and we measure north and south. Okay, so the line of longitude is 117 degrees 45 minutes. That's right along this edge right here. And we're going to add in minutes. So we start at 45 minutes, and we head to 50, to 55, and then to finally to 180. And so we're adding minutes in 5 increment segments here until we get to 180. So there's 1, 2, 3. So this is 5 plus another 5 plus another 5. Okay? 3 times 5 is 15. If we add 15 to 45, we get 60. Right? So actually this could be 117 degrees and 60 minutes. Now we don't write it as 117 degrees 60 minutes. What we do is we add that 60 minutes because there's 60 minutes in 1 degree, we can turn it into just 118 degrees. And in this case, 0 sits over here, okay, 0 degrees, so we're measuring to the west. So it becomes 118 degrees, 118 degrees west. Now, for a line of latitude, it's 40 degrees and 30 seconds. It sits right on the line, and so that one's an easy one to read. If we come down to the bottom, we started out at 40 degrees 15 seconds, and we went from 15 minutes. 40 degrees 15 minutes up to 40 degrees 20 minutes, 25 minutes, and now 30 minutes. All of these increments are still at 40 degrees, and 40 degrees, and we're adding 5 minutes in each segment. Okay, so we start out at 40, 15, but we're going to add 5, 10, 15. We're going to add 15 to that, and we end up with 40 degrees, 30 minutes. And we're going to note that we're going from 40, 30 at the top left corner to 40, 15 at the bottom left corner. So that means the values are increasing from 0 here up to 90. So that means we're heading north, right? So this has got to be labeled with a north. All right, let's do a few more. I'm going to go ahead and erase this kind of messy business that I've just written all over here. We can practice reading a few more. So let's take, for instance, C, right? So let's start down at the bottom right hand corner. So we're down here. Okay. Let's measure lines of latitude. So we're starting with 40 degrees 15, and we're counting up to what is 40 degrees and 20 minutes, and we know it's north. Now we got to measure from the small to the big. And so one point I should make here before we get too far into this is that you always are adding minutes and seconds to get a bigger number. And so we measure from the small number to the larger number. And so in this case, I'm starting at something that's written out fully at 117 degrees, 45 minutes. And I'm measuring in this direction like this till I get to 117 degrees and 50 minutes. I've added 5 minutes to this original value, right? So it's an addition from small to large. If I went to the next one, right, I'd be adding another 5 minutes. And so now I'm at 117 degrees, 55 minutes. But since I'm right here, I'm actually at 117 degrees, 50 minutes to the west. Okay, so that's for C. And we can move on and maybe try one more that's a little trickier, but I think it will make sense to you as we get there and work on it. That would be D. D sits in an interesting place here. It is both halfway between those two lines, or lines of longitude, and it is halfway between the lines of latitude here as well. So we know we have 40 degrees. We're starting with 40 degrees. We can measure up. Okay? We can measure north, in this case, or up on the page, till we get to here, and we would say, well, this is 40 degrees and 25 minutes. And that's useful, right? But it's not precise. How do we know what this value should be? Well, if we know that this is 30, we know that it's D sits in halfway between 30 and 25, so we know that the span here is 5 total, 5 minutes, and halfway, or half of 5, is equal to 2.5 minutes. So we know that it's going to be then, we're going to be adding 2.5 minutes to this 25 value. So it becomes 40 degrees, and then we're going to add in to 25, 2.5, and that's going to be 27.5 minutes, right? Now, could I write this another way? I certainly could. It could be 40 degrees, just fix that, 40 degrees, 27 minutes, and 30 seconds. because there's 60 seconds in every minute. Okay? Now, that's for something that we're measuring to the north, so that's our line of latitude. Now we're going to measure in this direction to the west, so we're going to have a western measurement here. And we know it's going to be 117 degrees. We're starting out at 45 to 50. That's a total increment of 5. Okay, but we got to cut it in half because we're halfway between. So that means we're going to add 2.5. So it becomes 117 degrees. And then 45 plus 2.5 is 47.5, or 47 minutes and 30 seconds. Okay. You can go ahead and take a minute. It might be useful to write out B, to write out C, and to even give E a try if you just pause the video and see if you can write them out. All right. So the last thing we have to deal with here a little bit with topographic maps is how is this stuff written out on the page, right? Where is it on the actual map? So what I've done is I've taken a small section of a 7.5 minute topographic map. I've cropped it, and so now all we have is a small area to look at. Normally the map would be about probably 7 or 8 times bigger than what you're looking at now, but this should have all the parts we need. Notice in the bottom right hand corner we've got 87, 52, 30, so 87 degrees, 52 minutes and 30 seconds written out, and that's for longitude. Okay. Notice it's at the end of this line, and then we get 42 degrees, 0 minutes, and that's at the end of this line. Okay. Horizontal lines are lines of latitude, and vertical lines are lines of longitude. Great. So I'm going to go ahead and erase this and clean it up just because it's going to make more sense if I start drawing on it and we'll get too complicated. So on this particular map, we're going to look farther to the west here and see if we can find an increment, another increment of latitude, and indeed we do. Notice it's 55 minutes. So this is 87 degrees, 52 minutes, and 30 seconds. Okay, this is actually written out fully, would be 87 degrees, 55 minutes, and 0 seconds. Okay, so 55 minus 52.5, or 52:30, the total distance there from here to there is 2 minutes 30 seconds, which is equal to, or the same as, 2.5 minutes. Now, let's say I wanted to know the location of something. Well, you can measure this quite precisely. You can work it out quite precisely. I'm not going to do that, and we're not going to do it in this particular lab. But let's say I wanted to know what the measurement was for the longitude of Des Plaines Lake. Okay, so I'm interested in figuring out, if I draw a line down, I need a line that runs right through it down to this base. And what I notice is that I'm halfway between 55 minutes and 0 seconds and 52 minutes and 30 seconds, but all within this 87 value. I'm halfway, so that means this distance here that I'm going to add to this value, 87 degrees, 52 minutes and 30 seconds, is going to be half of 2.5, and that's going to be 1 minute, and half of a half is a quarter, or 1.25 minutes, which is also equal to 1 minute and what's a quarter of an hour, or a quarter of 60? It's 15 seconds, right? So the longitude then for Des Plaines Lake, if I was to write it out, would be 87 degrees, 52 minutes and 30 seconds, plus 1 minute and 15 seconds. So that means the longitude is 87 degrees, 53 minutes and 45 seconds. All right, and so that corresponds to this location right here. If we needed to measure north, well, we need to measure a line of latitude, so that would be a line that cuts through just like this. Now you'll notice there's no measurement there, but up here out of reach, there's actually a little another little increment that it is 2 minutes and 30 seconds. Okay? And so all these distances, these increments, these subdivisions are in increments of 2 minutes and 30 seconds on this particular size of map. And so that means that I'm probably, or very close to, in this case, this is probably close to about 1 minute and 30 seconds. Okay, so if I was to write that out, I'd add this 1 minute and 30 seconds down to this 42, and so a close answer would be, without these increments written out, it's sort of hidden on this particular map. The close answer would be that this line of latitude was 42 degrees 1 minute and 30 seconds to the north. Okay, so that's your latitude for Des Plaines Lake, and this is your longitude for Des Plaines Lake. And that's how you read it on a much smaller map. The larger the map, the larger the globe, the less detail, and you potentially won't need to use degrees, minutes, and seconds at all. All right, so that concludes our discussion of how to read latitude and longitude, its units, and where it originates from. And we'll move on to our next segment, which is going to cover the additional 2 types of coordinate systems, the Public Land Survey Coordinate System and the Universal Transverse Mercator System.